Hey, you guys correct me if I'm wrong. Did we not yesterday? We did that problem, right? Okay. Okay, we did do that one. Showed you guys the trick, the reduced row echelon form trick. Okay, so what we saw here is yesterday then, when you guys know how to interpret these matrices from the work we did with matrices, but when you see a completed matrix that's been put into reduced row echelon form that looks like this, that means a single solution, right? How come? How can we look at this immediately and see that? Well, here are the clues. Those are zeros. Those are zeros. The final row or the final column are solutions, right? They're numbers. And the descending diagonal, oops, I kind of missed that, didn't I? The descending diagonal are all ones. So what's that really telling us then? The first row is just simply represents the equation, whatever our first variable is, which is we're going, the order is X, Y, Z, W. You could put the W first and go alphabetical. It's fine. You just have to be consistent. The first one is telling us X equals 2. The second one is telling us 1 times Y equals 3. Third row is telling us Z equals 0. And the last row is telling us W equals 1. So if we wrote our answer, it would be an ordered quadruple. Okay? And if we had the capacity to graph each of those rows now would correspond to a four-dimensional thing, right? It would correspond to a four-dimensional object, and the intersection of those four-dimensional objects would be at this point in four-dimensional space. But obviously we can't do that. That's what would happen if we could, if we lived in a 4D universe. Okay, try this one. Everybody just bust out your Chromebooks and try that one. Solve that system using the Desmos matrix calculator. Yeah, we know this one is no solution because if you look at the bottom row, what is that equation? Okay, so if we look at the new Desmos 3D calculator here and we look at this system and kind of see what's going on, we find, I showed this to you yesterday, right? Oh, I didn't? Oh, this is pretty cool. So yeah, if you go into the 3D calculator and I put in this system, if I graph the first equation, look what it does. It looks better if you go to the graph settings and do translucent surfaces. There's my first plane. There's my second plane. And I'm going to twist this thing around a little bit. There's my third plane. So how come there are no solutions? Yeah, look, the green and the red planes are parallel, so they never intersect. Okay? That's kind of a cool little calculator. You got to check this one out. It's Desmos 3D. It's a little bit buggy. It's in beta mode. You can't do some things that I'm hoping eventually you can do, like find solutions, like points of intersection and stuff. It doesn't do that, but that, I don't know, for an online tool like this, it's pretty good. Let me get a picture. There we go. That's a good picture. Okay, just for your notes, I'll put that picture in there. If we go back to the last one and we look at this guy, look at this system. Look what we see. This one had a single point, and you can see the single point. It's like there's a good view of it right there. Everybody see that? There's the one point of intersection right there where all three planes intersect. Okay. Okay, how about, let's try another one. Try that guy. Everybody got that, right? Okay, how do you, oh, whoops. Everybody got that, right? So you found that, right? The fraction button, the convert to fraction button is, you can use it with matrices too. Very handy. That's it, yeah. And anything's off on your matrix, obviously it's gonna ruin the answer. So how do we interpret this? What's the bottom row telling us? Yeah, it's telling us 0 equals 0, which means there's an infinite number of solutions. But there are multiple different ways you can have multiple solutions. You guys tell me, just visualize this in your head here. What are the two different ways that three matrices or that three planes could intersect to produce infinite solutions? Okay, they could all be the same plane, which would give us lots of freedom, right? That would be any point in any one of the planes would be a solution. What would be a slightly more restrictive way that still gives you an infinite number of solutions? If they intersect on a line, yeah. So how do we know which one it is? Well, you look at the top of the matrix and it tells you. In this case, they intersect on a line. And we can tell because of these rows right here. Like if you look at this one, what's that one really telling you? Yeah, x plus 1/7 z equals 0. In other words, that one's telling us x equals negative 1/7 z if I solve for x. Agreed? How about this one? What's that one telling us? Yeah, y minus 1/7 z equals 0, so y equals positive. If I isolate the y, 1/7 z. Okay, so what's that telling us then? We've got a free variable. Our answer would have to go into row B, right? There's an infinite number of solutions, but they're of the form where they're constrained, where z could be any real number. X would have to be this, right? So this one is going to be negative 1/7 z, and this box would have to be y is equal to positive 1/7 z. So z could be anything, but based on the value of z, that's going to constrain the values of x and y so that this produces a line through space. The intersection is a line just traveling through space. So you can tell when you get this kind of a thing going on, when one variable is free and the other variables in a 3x3 matrix, the other two are defined in terms of that third variable. That tells you this has to be a line. Let's look at this in Desmos and just verify that. In Desmos 3D, I guess. I got to specify we're using all kinds of Desmos calculators. Okay, there's the first plane. There's the second plane. There's the third plane. So the first and the third, the green and the red, are the same plane. Therefore, the blue plane has to intersect, all three of them must intersect at a line. And there's the line. Okay? And if you really look at this, you can even see that that's the line predicted. If z could be anything, like if I looked at the xz plane, now it's the wrong orientation. I don't know how to, I'm not very good at this video game here. I can't really twist this thing, but maybe you guys can figure it out. If I could twist this so z were the horizontal axis, it's the input variable, and x were the vertical axis, what's the equation? Well, it would be x equals negative 1/7z, wouldn't it? Right? Because look at the slope. The slope would be negative 1/7 then. If I twisted this so the y-axis, there's y right there. So if the y-axis were, I guess I'd want to do it this way, wouldn't I? If I twisted this one so the y were vertical and the z were horizontal, now I'd have a slope of y equals 1/7 z, right? I'd get a slope of positive 1/7. So you can even prove to yourself that, yeah, this makes sense. I mean, it's giving us the correct line, okay? Where's a good picture of this? There's a good picture right there. Okay, for our notes. There's a good picture. Okay, try one more. Try that guy. Oh, yeah. Whoops. Mm-hmm. Did you guys get that for your answer? Okay. Well, how do you think we interpret that? What is it? So the bottom row is true, isn't it? So we know it's infinite solutions. In fact, right? If if every row except the top one are all zeros, so they're all just everything, they're just saying true, and I get only the top row, isn't that just telling me? Yeah. That the intersection is that single plane, which notice is our one of our, that's the simplified version of all three of those, right? Okay. So if we look at this one, yeah, we should see in this case that they all overlap completely. First plane, second plane, third plane, all the same. Okay. All right, so